draw the diagram on your script. Some students, I think they don't draw also because whenever they see the teacher draw, oh, I can understand, but they didn't know that that was actually part of the solution. They thought that was just a discussion. Okay, so let's try. We have a line L, and this line L is the intersection between two perpendicular planes. Let me just draw it. So let's say it is this, two perpendicular planes. So for how I think I'm going to draw, right? I'm going to draw this way to symbolize that these two planes are perpendicular. We have a pi 1, we have a pi 2. Okay, so according to the question, the line is this. We have a line L, and this line L is R is equal to lambda 1a minus 1. And we have pi 2. Pi 2 is R dot B5 minus 1 is equal to C. Can we pause a bit to just rehearse and practice this inference thing? Okay, before we continue to do the question, okay? So I see this. Is there something that you can infer that you can maybe plant it into the diagram? Okay, it may not help, it's just for our this is really for our discussion, okay? So this one, are you able to infer from the theoretical equation that is given to you that you will actually have a point O, origin, that is going to be lying on this line L? Can see this? Okay, everyone can see this, right? Okay, in case you cannot see this, it's just trying to get another perspective of the typical equation of line format. Okay, if I were to write this into the typical format, then this will be what? 0, 0, 0 plus lambda of 1a minus 1. Okay, so I know 0, 0, 0 must lie on the line L. Of course, another easy thing to infer is definitely 1a minus 1. Okay, we are trying to pause to infer. Okay, so 1a minus 1 is parallel to the line L. But for this particular situation, are you also able to see that 1a minus 1 is also parallel to pi 1? 1a minus 1 is also parallel to pi 2, correct? Okay, can see this, right? Okay, again, like what I was telling you, if you cannot see, do tell me. I want to try to describe it again. But ultimately, the seeing part is your responsibility because no one can tell you, how to see. Okay, you must just try see, okay? Sounds very harsh, but yeah, it's a harsh word. So this line this vector 1a minus 1 is parallel to L. According to the scenario, it will also be parallel to pi 1. It will also be parallel to pi 2. In fact, can you see that this C here is actually 0? Are you able to see? C is 0. It's pretty obvious that C is 0 to me. Because mathematically, right, physically, if the point O lies on L, that means point O lies on pi 2. If point O lies on pi 2, that means I can just do a bit of mental sum. 0, 0, 0 should satisfy this equation. 5 minus 1. Okay, and that's why I know C is going to be equal to 0. Okay? After you have done it once, the second inference will actually be way faster. Sometimes you don't even need to infer or whatever. It's just natural to you. Like for example, this I don't know what is this, but I know here is going to be 0. Obviously, I've already done it once, if the point O lies on the plane, then this part must be 0. This is how I accumulate my experience to exponentially reduce the time that I spend on questions. If you keep referring, your time spent will definitely decrease on. Because whenever you refer, you rely on the experience that you have. If you don't refer, every time when you want to solve this problem, right, it is almost like new, That means you never will be able to reduce your time that is taken. Every time it is new. Every time when I want to drive a car, I need to invent the wheel first. Buy one wheel, fix it there, and then drive off. So I have this. I think it is enough of inference. Let's see what we have in part 1. Goodness. I think we have already solved part 1. Let's look at part 2. Part 2, we want to show that 5a plus b is equal to minus 1. A is here. Oops, let's do one more thing that I probably should do, which is this. Right, there's this b5 minus 1. So this is the normal b5 minus 1, which is lying on pi 2. So what the question wants me to do is to relate A to B. Okay, so it is pretty obvious that I'm going to try to find a relationship between this vector and this vector. So what do I see in these two vectors? They are perpendicular to each other. right? Okay, you need to, it's easy, but you must understand the process. You need to see that they are perpendicular, then you apply the math. Okay, the process is very, very clear. So I saw that they are perpendicular, then I apply the math, b5 minus 1, and let this be equal to 0. Okay, I mean, there's no way for me to apply the math first. Okay, so vectors, the process is very consistent. Okay, C first, apply C first, as in like C first, then think about the concept to calculate for it. So from here, we have a 5a plus b plus 1, bring it over to the other side is minus 1. So we have this. Part 3. Part 3. Part 3, given that vector 1, 2, 0 is parallel to pi 1. Let me just draw it. Let's say it is here. Okay, let's say this is the vector 1, 2, 0. Okay, so vector 1, 2, 0 is parallel to pi 1. Find the value of A and B. Can I give you maybe 2 seconds? I want you to think about it. Think about how you will do this question. Find A and B. With this information that is given, find A and B. Do you feel that you are reminded of a question that we have just discussed? You know what this question reminds me of? This question here, right? It reminds me of the VJC question where X was missing. It reminds me of this. That means the usual way that we are more used to in secondary school is they give you every piece of information. Okay, can you see? This is like the X that is missing. Because, right, they are telling you that you find this A and B. Okay, if this were to be a secondary school's question, between part 2 and part 3, right, there's probably going to be another part 2.5. And part 2.5 will give you another piece of instruction and help you to find another equation that relates A to B. Then part 3 will come, find A, B. You know, that's a secondary school style. They'll give you all the instruction that is needed in order for you to solve the problem. So now, they pluck out that 2.5. Okay. So you're supposed to piece the puzzle together. If the question were to ask me to find A, B, A, B are this number A, this number B. To find two unknowns, I'll probably need 2 equations. Because if I have 2 equations that are in terms of A, B, I'll be able to solve simultaneous equation to find A, B. So this is my strategy. Especially in part 2, I already have 1 equation in terms of AB, which means that in part 3, right, I'm going to make use of this additional piece of information to work out the second equation that will involve AB. Okay, so this is my general strategy. How am I going to work out the second equation? Let's see the information that I have. I will definitely need to use this. I will definitely need to use this and this. Okay, because I am looking for another way to form another equation that is in terms of A, B. Let's see what we can do, okay? So, is there something physical that I can see about this vector, and this vector? All these 3 vectors, they are actually parallel to pi 1. Can you see? All these 3 vectors, they are parallel to pi 1. I think these 2 are definitely obvious that they are parallel to pi 1. But if I have a vector that is perpendicular to pi 2 and pi 2 is perpendicular to pi 1, right? Then this vector should be parallel to pi 1. I mean, it's very easy to imagine. You know, I mean, this wall that is behind me is perpendicular to the floor that I'm standing. And me, which is the normal to the floor, right, is parallel to the wall. You know, so I'm definitely going to be parallel to the wall. What else? You know, it is something that you see all the time. Okay? It is just us pausing and trying to give ourselves a chance through solving problems like H2 math, right? To try to capture it more in a more factual and numeric way. I mean, you look at me, it's very normal to you, right? And I mean, it's very normal. I mean, do I stand like that? You know, I don't. You know, if I stand like that, then it's not normal. So you are already, like, naturally, you know that, hey, someone stand there, you must be parallel to the wall, if the wall is going to be vertical, you know. So it's just super weird. You know, but now I'm showing you that it's me standing there, but then your aim is try to make sure that you know that this is also parallel to the wall. So we have all these 3 that are parallel to pi 1. maybe I can do this. I can do a 1, 2, 0 cross 1a minus 1 because this will give me the normal to pi 1. And this normal to pi 1, if this is also parallel to pi 1, right, then the normal dot this is equal to 0. I will form an equation. Okay, so I'm going to do just that. So if I were to do a cross, this is going to be equal to minus 2, 1a minus 2. Okay, again, don't focus on the calculation when it comes to vectors, okay? If you do hyper-focus on how to do cross, you will never do vectors well. See it first. They are simple. They are simple visualization. How are we assured that they are simple visualization? Because all your vectors question consists of very simple dot lines planes, nothing else. So after a while, you realize that a lot of the visualization, right, they're actually repeating. It's very different from the real world, of course. In real world, they put there an aeroplane. Just go and find some vectors for the planes or the curve of the aeroplane. You see, there are a lot of variables, but not in our syllabus. Our syllabus only has point, lines, planes. So if you have to just keep visualizing, you realize that after a while, certain visualization, right? Like for example, this. I don't think about it much, because I've been doing this so often. But in case some of you, right, you are just looking at this for the very first time, you also don't want to become unrealistic and think that, oh, I must look at this and immediately tell that it is like that. When this is the first time, like today, now is the first time you are seeing this. Then since it's my first time, I'm at least going to see it first. Okay, I may take a while, but I know that if I were to get another chance, if I were to continue to do papers, right, I'll definitely get another chance to see something that is like this again. Then maybe I will expect myself to be a little bit faster. If I'm still as slow, right, then what's the point, right? So you must also be realistic to yourself, okay? What I'm doing here, right, is not what you may actually be going through because I've been doing this so many times. Okay, if it is the first time, you're slower, but after 2 or 3 times, right, then start to expect yourself to be faster. And this is the month, okay, which if you have been doing papers for the last few weeks, right, this is the month that you should be expecting yourself to get a little bit faster. So I have this, and like what I was saying, we will take minus 2, 1a minus 2 dot this b5 minus 1. I know that this is going to be equal to 0. Okay, you work this out, you're going to get another equation. A plus 2b is equal to 7. You solve these two simultaneous equations, you'll be able to find a and b. Can we try again? To prioritize our visualization. Then after we do our calculation. Okay, I'm going to skip the last part. Let's move on to another vectors question.